Hello everyone again, it's Doug Jackson from DougsWordClock.com. I've just hit the stop button on the camera, and this is the second part video of assembling a controller card. I've got another 22 minutes to go, so let's see if we can effectively use this time. So far we have installed the resistors, the little wire jumpers, the 3-wire jumpers. Don't forget the wire jumpers. They're very important to the operation of the circuit. The LEDs were polarized. Remember, there was a little flat part on the LED. We've installed all of the capacitors and the crystals and a whole lot. There's one crystal that in fact we've forgotten to install, and typically because it is in fact the smallest component on the board, we'll just hold the piece of paper underneath it, throw the component on the workbench. So hopefully we can see that. That is a tiny little 32 kilohertz watch crystal. So to install that, we just very gently place it in the holes that are labelled X2. In it goes. Gently splay the legs so it doesn't fall out, and solder it. Now, with these crystals, it is important when we're soldering them to not put a ton of heat into them. If you overheat a crystal, you can affect its accuracy. If you abuse a crystal, you can affect its accuracy. So you just have to be very gentle to it. Now, you'll be able to, when you finish soldering it, if you allow a little bit of extra lead length, you'll be able to maneuver it around so that it's protected in behind this this screw connector. Now what we're going to do is we're going to install all of the IC sockets. We install integrated circuits in sockets because that lets us remove the device if there's a problem. Now, if we examine an IC socket very carefully, we'll notice a few things. Firstly, there's a little detent in the top. That tells us where the top of the socket is, and it's important that it goes in the correct way, because when we're servicing it, we look for the detent to say this is pin 1, 1, 2, 3, 4, 5, 6, 7, 8. So the first socket to go in can be the little 8-pin socket down there. And these sockets are nice because they've got specially shaped legs and they just slot in. Now, when we put a socket in, we count the legs. Okay, 1, 2, 3, 4, 5, 6, 7, 8. If you only count 7 legs, it means one of the legs has folded under, and you have to take the socket out and look again. Also included are 2 14-pin sockets, and again we've got the indent at that top edge. It also has the number 4. This particular brand of socket has the number 14 molded into it. So instead of providing one 28-pin socket, I provide two 14s. I find that to be more sensible from a parts perspective. So again, 16s. Again, being very careful of the location of pin 1. So we just gently get all of the little pins lined up. In it goes. 1, 2. There's the third one. 3. And then the 18-pin sockets, and they go in this last spot here. 1, 2. Notice how I'm putting them in at an angle and then pushing them down. In at an angle, then gently pushing them down. Now, before we do any soldering, we double check that all of the pins have gone through. I can't emphasize that enough. If we miss a pin and it's folded underneath the top of the board, it is a real pain to fix. They're all there, they're all there, they're all there. Everyone's present. Everyone's present. Aha, bingo. See here, there's a pin with no socket through. So in fact we did bend the lead under. Let's take the socket out. See, no one ever got shot for double checking, and there it is, the little pin. It's folded under. All we need to do to fix it is just gently lift it back up, and thing of beauty. Okay, so in we go. And it's through. Okay, now that we've verified that all of the sockets are through, 17 minutes worth of the video left. Let's see if I can get all of these soldered in time. When you're making your board, of course, I strongly encourage you to be nice and gentle. Solder every single pin one at a time, making sure that you fill the pin area with solder gently. Now remember that we're applying solder to the pin and to the pad, not to the iron. So as you make more and more boards, as you do more and more soldering, of course, your soldering technique will get better and better and better, and you'll find that it's actually surprisingly easy. I have personally assembled boards that have had little microcontroller kit boards that have been a ton of fun to build, and they have had 60, 80 IC sockets on them, and you look at it initially and go, oh, that's thousands of connections. Give the tip a wipe. But methodically, you just one at a time, straight down, simple as that. Now, fume extraction. You notice that there's a little bit of smoke coming off the tip of the soldering iron. It doesn't bother me. Again, having been in the electronics industry for 30 odd years, what am I now, 47? Yeah, 30 years, 5 years, something like that. I'm not particularly fussed by it. Some people are, particularly concerned, and they go, oh, we have to use fume extraction. If you feel the need to use fume extraction, go for it. I'm still alive. Now, that said, I use lead solder. I don't use... here is an intriguing thing. With the projects that go out, we actually use lead-free solder, and we use proper extraction. When I'm just doing projects for me, just quickly here, in fact, Catherine does all of my lead-free soldering. She has all of the nice extraction gear, because quite frankly I don't want her breathing the lead-free fumes. The fluxes that are used in lead-free solders are actually not particularly nice. The fluxes that are used in lead solders have been being used for 60 years without any serious issues, and that's okay. So little bit of a dichotomy, because I'm assembling this and not Catherine. This little controller, which will stay here in Australia, is being made with lead solder. The controllers that go out will tend to get made with lead-free solder. That's one of those RoHS requirements by the Europeans. I'm not personally a great big fan. No, notice how I spotted a little joint that I wasn't happy with then. Just get in, touch it up, no problems at all. So there we go. Continuing through. You can see it's actually not a particularly complex task. It just takes up time. And I'll just do something here that I don't normally do. Very occasionally you might get a couple of You might get a couple of pins and accidentally short them together. To deal with that, I use a product which is called Soldering, and in this case we can simply apply a little bit of Soldering to the pins. It it uses a capillary action to lift the solder out. Then we can give that a little bit of a clean. 1, 2, simple as that. There we go. So we've now soldered every single pin. Okay, you'll notice that because of the type of solder that I'm using, I've just got a little bit of flux there, neither here nor there, but that's totally okay. So next we can install this 26-way header, and it just goes straight in, and solder that in place. 1, 2, 3, 4. This must be the most riveting video in the world, while watching another person solder. But at least you will have seen the entire process go to woe. Now, as I was mentioning before, with lead-free solder, it's important when you do use lead-free solder to use brand new tips that have been specifically purchased for the purposes of being lead-free. This old iron's got an old tip on it. There's no way it's going to be useful for lead-free solder. Lead-free soldering happens at a much higher temperature than normal soldering as well. I think, I don't know the precise numbers, but it certainly is like another 50 degrees Celsius on top of standard. A little logo there, DRJ, that's me. It's funny what I put on boards in reflection. Anyway, there we go. So we've now assembled this little board. We've got all of the joints are done. Everything's ready. The next step is to put in the ICs themselves, or integrated circuits. Now, if we look carefully, we'll notice that the ICs will typically have a U-shaped dimple at one edge. Let's grab another example, this microcontroller. You can see here there's a U-shaped dimple and a little dot for pin 1. I might go to the trouble of pulling out my white piece of paper to really highlight that for you. So you can see there's clearly the U-shaped dimple. That's the top of the IC socket. Let's have a look at the real-time clock chip and see what it has. Real-time clock chip down. Again, U-shaped dimple. That's all pin 1. Now, when you look at the legs of the IC, you'll see that they're splayed outwards. They are not parallel. Let's get that in where the camera can actually see it. This is proving to be fiddly. That's okay. So you can see that the legs are splayed outwards. So the way how I deal with that is I very gently lean the socket onto a surface until the legs are parallel. Once you've got the legs parallel, you can gently place the IC, and again remember, all of the pin 1s all face this edge of the board. So get the pin 1s lined up, make the legs parallel, gently slide it in. Let's do the next IC. Gently make the legs parallel. It's probably working a little bit high there for the camera, so I'll do the next one much lower. Gently roll it over. Gently roll it over. Find where pin 1 is. It's on that side. And gently into the IC socket, making sure everything's in place, and push down. Down we go. Microcontroller. Again, same thing. Very gently in. In we go. And down we go. This one these little drivers. You'll notice the drivers have 18 pins, whereas the little shift registers have 16 pins. It's actually, the board itself I'm very, very pleased with. It's a design that I got basically right in about 2010. Version 3 of the board was in 2011, and we haven't needed to change it at all because it's just reliable. So here we go. So you can see here that all of the ICs are in. So if we look very, very, very carefully, you can see that every single one of the legs has actually slotted into the socket, and we don't have any cases where legs have fallen out. We've got the little dimples, 3, 4, 5, 6, 7, 8, are all facing that way. So this board is now finished. How do we test it? Well, there are for you in your place at home. If you don't have your clock board finished yet, that's okay. What we do is we apply 9 volts to positive. You see the little plus sign down there? Little plus sign there. Positive, negative, 9 to 12 volts sits there. Now, the positive connection goes there, the negative connection goes there. So in my case, I'm just going to connect my little power supply to negative to the pin there, positive to that diode. First thing that we should notice is that the power light starts glowing. Now we wait. At the moment the board's doing a little self-test, and after it completes doing its self-test, we'll see the pulsing from the little pulse light. I'll get it up closer so it's really visible. Simple as that. So again, disconnect the power, connect the power. Maybe if I turn off the big light. Hey, that works really well. Cool. So again, we wait. So, and the pulse light will eventually start pulsing. There we go. And one more time and we'll time it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. A good 13 or 14 seconds. But as long as that little pulse light is flashing away, we know that the board is largely in one piece. So there we go. That is a short video about how we go about putting together a WordClock controller card. I hope that was useful to you. Take care and have a great day. Bye.